Hello everyone, welcome to the course Data Structures. This is N. Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In the previous session, we have discussed about the introduction to data structures with Python. Now, in this session, we will be discussing about the basic terminology and classification of data structures. We will see what is the overview of this today's session. The basic thing we are going to study about the basic terminology of data structures. Then we will be seeing about what are the different classifications of data structures and what is the difference between linear and non-linear data structure and what are the abstract data types we have. And at the end we will be seeing about what are the different operations on data structures we are going to perform. Let us see, these are the concepts where we are going to cover under Unit 1 as we have seen in the introduction part of data structures also we have been discussed, but once again we will see these are all the concepts where we are going to cover under Unit 1, that is basic terminology, classification of data structures and what are the different operations of data structures and abstract data types. In this session, we are going to cover up to this and the remaining concepts, that is linked list, that is what are the different types of linked list we have, single linked list, double linked list and circular linked list. These concepts with the implementation also we are going to cover in this particular course where you can implement this by using the Python, not by C, by using Python we are going to cover all these concepts. Coming to the basic terminology of data structures. As we know in the computer science, data structure is a data organization where not only organizing the data, managing the data and storing the data in a particular format. Now, why we need to do this? Why? Because if you want to access your data in a faster way and if you want to do any modification of your data, that can be done easily when we are going to store your data in an organized way or a structured way. And organizing, managing and storing of data is important, as I told you, because it enables easier access and efficient modifications. If you want to do any modifications, if you want to access the data very fastly, we need to store them in a proper way, in a structured way or in an organized way. So, data structures allow you to organize your data in such a way that enables you to store collection of data, relate them and perform operations on them accordingly. This is where we are going to have the basic definition of data structures. We can define in a simple way what is data structure is. The data structure is a way in which data is stored on a computer in an organized way. And what are the different classifications of data structures? Here, data structures in Python has been classified into two types. One is primitive and another one is non-primitive data structures. Under primitive data structures, as we have seen in the C language also, we have different data types we have, that is integer, float, string and boolean. And while coming to non-primitive data structures, we have some built-in and user-defined functions are there, right? Let us see in depth about what are these non-primitive data structures, which comes under built-in and which comes under the user-defined. When we will see about the built-in non-primitive data structures, where we have this list, tuple, dictionary and set, all these comes under the built-in. All these are predefined things that was present, just we can use them and we can implement them. And while coming to the user defined, these are defined by the user on his own. He can able to write his own data structure, that is by those are nothing but the arrays, linked list, stack, queue, tree and graphs. These are the different user defined non-primitive data structures where we can able to write our own defined functions. And let us see the difference between linear and non-linear data structure. What is linear data structure? Where the data is going to be represented in a linear fashion, right? And here the data will be stored in a sequential way. As you can see the definition here, in a linear data structure, Data elements are arranged in a linear order where each and every element is attached to the previous and next adjacent. As I told you, this is the way where we are going to store your data in the linear data structure. And what is non-linear data structure? Non-linear data structure means it is going to be represented in the hierarchical fashion, like this way. It will be in the hierarchy, like this way we are going to represent. And in linear data structure, single level is involved. As I told you, only one level will be represented, where in non-linear we are going to have multiple levels. This is level 0, level 1, level 2. Like this way we are going to represent. Now the next one, its implementation is easy comparison with the non-linear data structure. To implement linear data structure, it is very simple. Compare with the non-linear data structure, but for all the applications we can't use the linear data structure. That's why we need to go for the non-linear data structure also in some cases, like trees, graphs. In all these things we are not able to use the linear data structure, so we are going for the non-linear data structure. And in linear data structure, all elements can be traversed in a single run only. That means if I have been stored the elements in the single place, I can able to access or traverse one after the another easily. But when you are going to use non-linear data structure, it is in multiple levels. With single run, I can't able to access the data. Why? Because we need to traverse through all these nodes so that we can able to get the data. That's why it is little bit difficult to access the data. And the examples of linear data structures are array, stack, queue, and linked list, all these. And when we see about the non-linear data structures, trees and graphs are the examples. And last, applications of linear data structures, where we are going to use the application software development, and where we are going to use this applications of non-linear data structures under artificial intelligence and image processing. These are the differences where we are going to find with the linear and non-linear data structures. And coming to the abstract data types are nothing but the high-level data structures that provide an abstract representation of the data and the operations that can be performed on the data. Right? This is the one where we are going to have the abstract data types. They are defined by the behavior rather than their implementation details. How they are going to behave, that will be given in the abstract data types rather than the implementation, because allowing programmers to focus on the functionality and the usage of data structures rather than underlying the implementation. How the data structure is being used, that one we are going to concentrate in the abstract data types. We are not concentrating on the implementation part of it. That means how internally it is working. Suppose I have given some insertion, how internally it is working, that is not going to be concentrated. Just we have given the functionality of insertion, where we are inserting, that when we can able to understand, right? ADT, that is abstract data type, serves as a blueprint for creating concrete data structures. This will be given as a blueprint, as a basic building block, and based on that we can able to create or concentrate on data structures. Most of the data structures we are going to use this abstract data types. And what here data consists of? The data consists of the component specifies the type of data which it is going to take, that can store, that can not only taking the data, and that can be stored, whether it can be of any of the type like integers, strings, or any custom objects also, right? And the data consists of all these things. And when we are going to see about the operations, what are the different operations we can able to perform? The operation components defines a set of operations or functions that can be performed on the data. Those are nothing but where you can able to create a particular data structure or create a particular node or something, and how you are going to access a particular node, or how you are going to modify the data, and what are the, then we are going to deleting the data within the ADT, right? What are the different operations we can perform on a particular data structure? Like suppose in short we can represent ADT as data plus operations. Data plus set of operations represents an ADT. But here in ADT, the implementation part will be hidden, as we have discussed at the starting itself. And what are the different operations we can perform under these data structures? These are the different operations where we can perform, where we can have the creation, where a particular node will be created, or a particular vertex will be created based on the data structure which you have been selected, right? Creation is nothing but we are going to create a particular node or vertex or something, right? And we are going to have the insertion. Insertion can be done in the linked list. Suppose if I am going to consider a linked list, in that particular case, insertion can be done at any end. Either maybe begin or end or in the middle, before, after, or based on any position. In all these places we can do this, right? Insertion can be done. In the same way, deletion, a particular node can be deleted at the begin and what are the operations we are going to perform under insertion. The same thing we can able to delete also. And not only that, we are going to perform the searching. We can search a particular element is present in the given list or not. Or if I want to, in a tree also, if I want to search a particular element is present in the tree or not. All these things can be done. Concatenation. If I have given two lists, how can I concatenate? How I combine two linked lists and how I can represent it? That can be possible with this concatenation operation. And display or traversal. This will be able to display what are the nodes you have been created, what are the vertices you have been created. All these are going to be displayed by traversing. Traversing means moving from one node to other node or one vertex to other vertex. This is going to be displayed, right? These are all the operations where we are going to perform under these data structures based on a particular application. And let us see the summary what we have been discussed under this session. The basic terminology we have seen about the data structures, what is data structure definition, and what are the different operations, what are the classifications of data structures, and what is abstract data type, just we have seen about it. And what are the classifications we have been seen, primitive, non-primitive data structures we have been discussed. Under non-primitive, we come across built-in data structures and built-in and user-defined data structures we have been discussed. And coming to the difference between linear and non-linear, what are the advantages with linear and what are the disadvantages with the non-linear? In which of the cases we can able to use the linear data structure, in which cases we are going to use the non-linear data structures. These things we have been covered under this concept. And abstract data types. In most of the data structures, we come across these abstract data types. Why? Because all the implementations or what are the operations we are going to perform, all will be hidden, right? That's why these abstract data types are more useful in our data structures concepts. And at last, we have seen about the operations on data structures, where we come across concatenation, creation, insertion, deletion, and we have seen about the display also. These are the different things we cover under this particular session. I hope you understand this. We'll see the further concepts in next session. Thank you.